This division strategy is called proportional reasoning. We look at division as fractions that we can possibly reduce. So if we have 100 divided by 4, and I'm going to write it out horizontally just so we can see the process a little bit. We can most definitely reduce both of these numbers down because they can just be reduced. 4 can go into 100 a certain amount of times, and then 4 can be reduced by itself. So let's see what that will look like. So let's start with halving, I think it's splitting it in two. So 4 divided by 2, we would get 2. But we also have to make sure that if we're going to divide one side by 2, we have to divide the other side by 2, so we keep it balanced. So 100 divided by 2 is 50. These numbers can be reduced again. So if we divide 2 by itself, then we have to divide the other side by 2. So we can reduce those. We want to have the fraction be reduced to a certain amount of times if it's able to get down to the denominator to be 1. So 50 divided by 2 is 25, and then 2 divided by 2 equals 1. So 25 divided by 1 equals 25. So 100 divided by 4 equals 25. And another problem can be 800 in fraction form, numerator over denominator. 800 divided by 40. Whenever we have a problem that has both the numerator and denominator ending in a 0, and they're lined up, we can definitely cancel that out. So now our problem is 80 divided by 4. We can reduce this starting with 4. Just off rip, we know that 4 can be halved. Reduced by 2, it's a multiple of 2. So if we do 4 divided by 2, we get 2. And we have to keep it balanced, so we divide 80 by 2 as well, and we will get 40. Now, if we were to reduce it again, because they most definitely can be reduced, we can reduce 2 by itself. 2 is a multiple of 2, so we divide by 2. We get 1. Keep it balanced. Divide 40 by 2, and we get 20. So the problem is 20 over 1, and 20 divided by 1 equals 20. So our initial problem, 800 divided by 40 equals 20. Yay!